Good afternoon. Thanks for coming to my session. My name is Feng Qu. I work for eBay Inc. in the global data infrastructure team. Today, I'm going to talk about something we have learned in the last few years. We use the Cassandra. So basically, there's some processes, there's some best practice we want to share with everybody here. We'll go over some of the usage at the eBay Inc. Also, we'll talk about how to develop a successful NoSQL application. It goes through the life cycle and what's the rule for each people and each group, and how do we make the whole thing a successful story. Also, we'll share some Cassandra best practice. At the end, we'll have Q&A sessions. I want to mention a little bit about eBay. In general, when we talk about eBay, we're talking about ebay.com, which we call the marketplace. However, eBay Inc. itself is a kind of a holding company. It has a lot of other sub-companies like eBay, PayPal, eBay Enterprise, Braintree, StubHub. All these things all belong to eBay. So if you look at the eBay stock sample, actually everything will be represented there. So that's where we are. As part of our operations team, we are basically managing both operations for the eBay marketplace as well as the PayPal. Sometimes we also managing the infrastructure for some other company as well, listed here. eBay is a very heavy database user. We manage 1,000 of the databases which power the eBay marketplace website as well as the PayPal. We are started with like an Oracle shop. We are one of the biggest Oracle user in the world, in the industry as well. Besides Oracle, we also use some cases using the MySQL relational database. In the last few years, we are starting adopt the NoSQL technology with using Cassandra. We are also using Mongo. We're using Codebase. This is a 3 official NoSQL product we're supported by the central database engineer team. Besides that, also at eBay, we use the HBase, OpenTXDB, Redis, all these different technology. But those technology currently are managed by the developer team themselves. Well, there's a few things we have to ask. So why do we need a NoSQL? Because initially, we are almost 100% on the relational database. There are a few things when we talk about the traditional database. There are few challenges we are facing, and it's harder to resolve in the RDBMS world. One thing is because you have to manage the AC features. That means there's a lot of extra extra work inside the database software you have to manage. That means from the user point of view, there's a performance penalty. Also, if you think about Oracle or MySQL, they don't really have a very native sharding, which give you a linear scalability. If you go Oracle, normally when you need to scale beyond one node, you use an Oracle rack. However, using rack does not give you the linear scalability. If you go from a single instance to a 2-node rack, normally you can see 50–70% extra improvement, but you're not going to double the performance or throughput. Similar thing with the MySQL cluster. Because we're used for the traditional RDBMS, it's hard for you to scale out by adding more nodes. The choice is there, you have to scale up. So that means you have to buy more, keep upgrading your hardware with more cores, more memory, faster network. So those high-end hardware is very, very expensive. For example, in one of the PayPal system, we are using the biggest IBM machines. This is very, very expensive. Not only for the hardware, but as well, those regular, like RDBMS, the software license is also very expensive. So all this translate to, in order to support same amount of transaction, for example, in our system, we support hundreds of billions transactions across all the database every day. So each of the commit average cost in the our database world will be much, much expensive. So because of the challenge, we are starting looking for alternatives. Based on the different use cases, we are starting using different technology. Some of the use cases we can see is a lot of write intensive. It could be using Cassandra if you do some caching here. Codebase could be a choice. Also, for some of the document data store, we're using Mongo. Also, different use cases. For one of the logging platform, we're using OpenTXDB. So that's all the choice available to the user, which means as an eBay is a very large website, there's a lot of different features. Not all the features can be supported by a single database platform. We have to provide a choice to developer to give them the best data stores. Here, a look at the Cassandra usage from eBay. We started about almost over 3 years ago, and we started from the marketplace. Then we later on expand to the PayPal side. We start in the beginning. We start with the Apache 0.8. That's more than 3 years ago. Now, a lot of our production cluster was running Cassandra 2.0, and also a lot of mission critical cluster were running the DataStax Enterprise. Initially, I was pretty proud of our scale, but I just came from the Apple talk, right? If we look at there are 75,000 nodes, this number wasn't no more impressive. Definitely, there's a lot of catch-up work for us to do. Hopefully, when I come back next year, we'll get some little bit different numbers. Yeah. Just for ourselves, when I was presenting last year, I was representing for the eBay marketplace. So at that time, for the past 12 months, we almost doubled our usage. Also, if you look at here, one of our kind of auditing archiving system from the PayPal side, it will, based on the utilization estimate, it will grow to a few terabytes itself, just for a single cluster. So this is we just started ramping up. So hopefully, because the data will keep coming in on a daily basis in a year or later, so this system will also itself just handle a few petabytes. Now I want to talk about how do we handle here. Today, I think my focus just want to see you have to, in order to get a successful NoSQL project, you cannot just work separate. Developer cannot just focus on coding. Data architect or either operation, they cannot just focus their own area. So based on our experience, you have to work together. For example, I'm mostly from the operation side. However, I'm not just let developer, data architect develop application. We starting getting involved only when the application ready to go to deployment. So normally we start pretty early. So for example, if you look at the chart, normally people start with use case analysis, right? Business people ask for a feature, engineer talk to them, get the requirement, and then work with the data architect team to design the data model. In the traditional method, right, we are, as the operation side, we are not really involved in data modeling side. However, at eBay, we are involved almost very beginning. So we even involved at some kind with the use case analysis. We want to know what does the business require? How do they translate to the data requirement? So that gives us early involvement so we can provide our feedback or input when they do the data modeling or when they select the right data store, because we have so many choice for user to pick. So that gives us, based on our experience, so this definitely helps a lot. We don't have to wait until the operation stage to find the problem, right? We can give us input, help with the developer design the data modeling to suit the particular data store. Then that gives us a benefit before we go to production. We already know what do you do, what's the purpose, and how the data is laid out. once you have a data modeling, right, you know basically it's a logical model. Then you have to translate how much hardware do we need to support your requirement. It's not just like we only support you when you start to launch. We need to think about a little bit ahead. That's where the capacity planning came inside. So normally when we have the system, when we're starting to sizing hardware, we are looking for at least 12 months forecast about the utilization. So when we ready to deploy a hardware, we know if everything estimates are correct, you don't need to make any adjustment on the hardware side within your 12 months. That's where we work with the engineer team, data, also as a capacity team, because for eBay, it's a very large website. So capacity is a very critical rule. They are basically monitoring the system whole set utilization on a daily basis. They also have their tool as their model. They can proactively identify the shortage of the capacity, and instead of waiting for the problem occur, they can just try to solve this problem or prevent the problem from the early days. Once we have capacity finalized, we know how many server, what's the layout, how many data center, how many data copy we need. Then we are going to deploy the whole system into production. After that, you have to let the system running, make sure everything runs smoothly without problem. Only at this point, we can see this will become a successful project. It's not just like you finish the code, you are done. We have to make sure it can meet the business requirement, can deliver what your expectation. Now we can go to a few detail on each of the phase. So as the data modeling part, it's a pretty standard process, right? Development team work with the data architect. Even for the NoSQL, it's famous for those flexible schema. However, when you go to the enterprise or either the large e-commerce website, you have to be careful when you design a data model. Because if you make the wrong or either suboptimal choice at the beginning, it's hard for you to correct the problem at the end when you find the problem. So when the developer and the data architect work together, they design basically a logical data model. They know, in the Cassandra example, so how the data should be laid out, how many column family, and whether, how many copies we should get based on the business requirement, like a consistency requirement. Once we get it done, we're going to have a set of the ticket inside eBay process. We track all this information. Data modeling side, I think this most people already know, because if you come from our relational database, it's very different, right? Relational database, you model around the entity. On the NoSQL world, particularly on the Cassandra, you basically modeling around your query pattern. How do I want to access data? Then I design data modeling reversely to satisfy your query. One of the basic rule is that you probably need one column family per query. Another thing you need to keep in mind is the denormalization. So in this here is we don't mind to store multi-copy of data as long as you can give me the faster query response time. That's one of the NoSQL, the way to use NoSQL. Also, you need to separate a different type of data based on their utilization. User read-heavy data or write-heavy data, you should trying to separate them logically, even physically, to improve the overall caching performance. We have one of our former colleague, his name is Jay Patel. He's also a frequent speaker at different meetup, also previous summit. If you Google his name and also the data modeling, he published a few tech blogs that you can look at how does the data modeling work inside the Cassandra world. Just a few words on the indexing. Cassandra itself have a built-in, we call it secondary index. Other ways you can use the column family as an index. So there are some pros and cons, right? Secondary index, because it's built-in as part of Cassandra, it will be relatively more efficient, less overhead. However, the problem with the secondary index is that does not scale very well with the high cardinality data. Just like if you from a relational database, you can think about this like a local index, right? When you do certain scans, you have to go through almost all the data nodes to retrieve a subset of data and to aggregate back. On the column family side, even application have to manage the data population for both the original column family and also the index column family. However, the performance-wise will be much better. It's just so you have to make a choice, right? In general, rule is that you should avoid secondary index, but you still need to design case by case, because certain case secondary, or for example, a low cardinality data, right, could still help a lot. For example, if you want to look at something by the zip code, right, it's a limited number of the things that could be helped with the secondary index. Well, now we go to kind of a capacity phase, right? Before we talk about capacity, one thing is critical is we need to do the benchmark testing, particularly for the large-scale application. The reason we do the benchmark is we want to know for the hardware unit we are supporting, how much performance capacity we can get from those kind of unit. For example, if we talk about a particular machine with a 20 core, 128 GB memory with 1.6 terabyte SSD, how many read-writes we can get? For example, using standard YCSB benchmark, right? So that gives us, whenever you have change your type of hardware, different cores, different memory, or even different storage, either local SSD, local spindle disk, or either network attached, right? Either NetApp or either violin memory, flash array, etc. So whenever you have a change in your base unit, right? Also, not just hardware, but also like a software. You get Cassandra 2.0, now you get 2.1. That could be a lot of improvement. Same thing with the use case, right? Some use cases will be read intensive, some will be write intensive, some will be mixed workload. So any of those parameter change, you should build a performance baseline. From only when you have an accurate baseline, you can have a better capacity planning. Otherwise, you could end up seeing the surprise when you go to the production. The concept is, capacity is rather simple. You want to find out the base unit performance and then calculate the requirement. However, we have to know the business requirement could be changed. So this capacity planning and capacity review process is first is proactive. You have to decide, how much capacity you need upfront. Additionally, you still need to do a routine capacity review, which we will talk a little later, to review the capacity utilization and see whether you need to make adjustment or not. Most of the time, you need to add more hardware to increase capacity. Sometimes, very rare, you could end up with over-provisioning. Then you can downsize the cluster to get a better return of investment. So capacity-wise, if you look at the process, we definitely know we want from business side we know how much capacity we should need. For example, we need to support 20 million reads per day, or either 10,000 peak read per second, etc. And also we have those performance baseline from with the benchmark testing we did earlier. So with all in the input, if you have a capacity model formula, the output you can see, okay, in order to support this requirement using our base unit, how much memory we need, CPU, storage, I/O network, etc. So you could come up with a number, right? You can see, okay, for this particular use case, I probably need 10 nodes per data center to support, for example, 3 copy data. You can use the local quorum for read and write. So this kind of the result we can get from a capacity planning phase. Once you get everything finalized, then it's time for you to procurement hardware. As part of the deployment, we know when we have to understand, how the kind of a physical layout of the hardware. For example, you better know, whether those once you get the servers, what fault domain are they at. So you don't want to put all your server, all your copy of data in the same fault domain, right? If you're on the same rack, if you lose the powers or if you lose the network link, then you completely lost the data in this data center. So you better to understand fault domain and arrange your server, accordingly. When we do the once we get the hardware server in place, then we have to talk about software deployment. Because at Cassandra, we're talking about 100 server at least. It's very lot of repeat work if you want to do everything manually. So we did some preparation work. Basically, we packaging all the binaries ourselves. Based on our experience from the benchmark testing or previous utilization, we make some customized optimization based on our environment. Whether, for example, the kernel level changes for those different types of storage, like SSD, you need to set up a disable rotational flag. Sometimes you need to disable the transparent huge pages. Sometimes you need to reduce the read ahead, right? All these things were pre-built in. And also, some of them are dynamic. It's not, even we put all the parameters there, some of them only be activated if meet the certain condition. If you don't have a SSD, we are not going to disable the rotational flag, for example. We can as part of a Cassandra startup script, we do some checking and set up some of the certain parameters on fly dynamically. Also, we have those some of the heap adjustment, like heap size and the new size, etc. Also, certain compaction throughput threshold, etc. Also, we're looking for ways to automate the deployment, right? When we set up a cluster, we have tens of machines, or sometimes almost close to 100 machines to deal with. We are trying to automate this process as much as we can. We haven't as the 100% automated at the moment, but we're kind of working on it. I think it's a very good investment up front. If you can go to the NoSQL world, you should start with investment in the beginning to build some tools. Long term, you're going to get very good returns. At eBay, we have multiple data centers. So basically, we have a data center in SLC, Salt Lake City, Phoenix, and Vegas. So we're all our data center in the West Coast. So when we deploy the Cassandra, we always have a 3 data center deployment. So let's give you a load balancing because we have all the app server across 3 data center. So you should give them local access to Cassandra. Also, with Cassandra, you have those built-in disaster recovery. If you lost one data center, you also always have the data in other 2 data centers. So you still can function even you lose 1 or even 2 data centers. Since 1.2, Cassandra has the vNode capability. We have learned kind of hard lessons because some of the cluster we start with from 0.8 or either 1.0. At that time, vNode is not available yet. So now, once the system grow bigger and bigger, those hard token, the setup is definitely the pain for us to scale. Right? For example, when we need to increase the capacity, in order not to run the big, massive data movement, we have to double the size of the cluster. Basically, we split 1 into 2 and do a clean half the data. If you want to increase by 20 or 30%, then you have to recalculate, assign a token. There'll be background a lot of massive data movement. So definitely, if vNode become a mandatory for us for all the new setup, and also we're looking for the convert the previous non-vNode cluster to the vNode because that's even that's a very complex process. Actually, we we do have a one ticket open with the DataStax support to finalize the plan. For example, we have a 1.2 cluster without vNodes. We want to go to the DataStax Enterprise 4.5 with vNode. This process is very complicated because we also have multiple data center. How do we do this without downtime? So that's a very complicated process. So if you have a time, if you have, if possible, just use this at the beginning. There are a few operation practice because I'm coming from operation side, so I need to understand how the system works. It's on the day-to-day basis, also on the look at for the historical data, watch for the trend, right? So it's very critical for you to set up something to collect the system level as well as the database level metrics. So we do leverage this GMX interface to get some internal metrics. We also leverage the CF stats, etc., to both to get the metrics. So right now we have a setup to retrieve this metric every 15 minutes. Then we calculate data aggregate on a daily basis. So we can see in the past 20 hours how many rows in column family, how many read-write operations. Now we also watch the system level, for example, how many garbage collection we have done, what's the total time, what's the maximum, what's the average, what's the mean time. So that give you, with all this metric data, can give you a better idea the health of the cluster and help you to better manage the system. We also need to monitor the system to see its availability as well as misbehavior. So there are two types of alert we're kind of generating. One is based on the event, right? Whether Cassandra is up or down, that's kind of is based on the event driven. This kind of need a real-time notification. Also, we have a metrics-driven alert. For example, how many pending, whether your pending completion is keep growing or not. If you're reaching certain threshold, we want to generate a type of warning. Same thing with the storage usage. Also, for example, the garbage collection frequency, also the overall time. So we have to generate those those kind of alerts. Also integrate with our network operation center. So we do have a different group of production DBA. They are shifted between US and China. They are monitor the whole database system 24/7. In order to run a production system smoothly, we do need some document, some operation. For example, document what's the standard procedure to start Cassandra, stop Cassandra, as well as to debugging, etc. So we do document those best practice process. This gives us a chance to reduce the human error. Also, we do, based on our past usage, we set up a certain performance tuning runbooks. So which tool can you use to look at a certain problem, right? For example, we have no tool TB-stat, we have no tool CF histograms. Also, we have our data generated from those daily 15-minute metrics. So we can look at and try to identify the problem and take action accordingly. So Cassandra is based on the commodity hardware. So when you design a Cassandra, those nodes may be up and down frequently, right? Not only the hardware, sometimes you may see Java auto memory, the Cassandra crash, it happens. So you have to know for each different error cases, how do you handle that? How do you handle it without any delays? So we have to document the troubleshooting runbook. So if you look at the operation side, we do a lot of documentation and make it available not just to NoSQL expert, but also to regular DBA, because our DBA in the NOC or even our own team, they handle everything. We don't have people only knows Oracle. We don't have people only know Cassandra. So the people we have to be expert on the Oracle, MySQL, Cassandra, Mongo, Codebase. So when they on call, they are the only person deal with almost everything. So we have to utilize documentation and what we learned before to share to improve the knowledge across the team. There are certain operation practices like repair, and another way we're using for the client configuration, we're using CNAME, because hardware often failed. When we get a replacement, we get a different hostname IP, right? Using CNAME easier for us, operation-wise, to transfer from one machine to a new machine without changing configuration on the client side. Another thing to pay attention is GC grace, because we're dealing kind of large amount of data. Depending on your TTL, the default GC grace like 10 days may be too big. For example, if you have a TTL with 7 days, leaving as a default 10 days, which means you almost more than double your data storage. So that's a few things you have to pay attention. Just mentioned earlier, capacity review is definitely a hard requirement. It's a must, right? You have to look at this periodically and trying to identify the scaling bottleneck and solve it accordingly. So even for NoSQL is good at scale out, but you have to look at case by case. From our experience before, right, we do see some use cases we can, at the component level, we can do a scale up. For example, if we have a network bandwidth issue, we can upgrade from a 1 gigabit network card to 10 gig, right? That's give you a better network throughput. On the I/O latency side, we can upgrade from spindle to SSD, or from low SSD to a better SSD. Same thing with the storage. We can use the network attached storage to expand the data volume. So all these different cases, what I'm trying to say is, instead of always scale out, which means you add the nodes with more memory, more CPU, or the more storage, it's better for you to look at it first to see if whether it's more efficient, just do a component level upgrade. That's a typical use case. Even Cassandra, mostly for the write intensive. We also have a lot of different use cases for the read intensive. So for example, we have a matrix collection logging. That's the write most and less read case. We also have a whole page feed. If you go to eBay.com, you will see there's a feed stream. So that one is basically coming from a recommendation backend. Though all this data was calculated, stored in the Cassandra. Also, we have another few cases is personalization. So basically, based on your own activity, we capture it, and when you come back to the site again, we can, based on your own personal data, to provide you a different user experience. For example, if you like electronics, right, the home feed or either other place, or search-wise, when you search Apple, if you are interested in the electronics, Apple more like means Apple product instead of the fruit apple. So all the data and also the classification, which means when you do the search, on the left-hand panel, there is a different criteria you can narrow down. For example, new, used, auction, or either buy it now. All these classification rules and also template are stored also in Cassandra. Here's one example. I don't want to show how do we utilize data. This is basically the matrix collection from the set. It's not about Cassandra itself. It's about how eBay runs, how the machine application server performs, right? If they're collecting a data where like 10-second level, then to aggregate it to minutes, 30-minute, hour, daily, or even monthly. Today, this pretty much is what I'm talking about. The takeaway from the talk is I want you to look at the NoSQL project from a different point of view. Even you are not a developer, you should look at how should I make an application scale while running smoothly in the operating side. From operating side, we need to better involve in the early stage of the project design. That gives us a better idea how the things work, give you more chance to support it in the production environment. Thank you very much. If you have any questions, feel free.